Hello, this is Mr. Wong and welcome to Wong Bio. If you get it wrong, just ask Mr. Wong. And today we are going to look into the most important molecule that makes life possible, water, or how my hometown would like to say it, water. And by the end of the video, you would be able to explain how the properties of water affects its biological function. In the previous video, we went over how an unequal sharing of electrons in a covalent bond can result in a polar molecule. Water happens to be a very polar molecule, meaning that its overall charge is unevenly distributed, with the oxygen end having a partial negative charge and the hydrogen end having a partial positive charge. Because of the polarity of water, with hydrogen atom that is covalently bonded to the electronegative oxygen, water can form a hydrogen bond with another polar molecule, such as ammonia or another water molecule. As you can see in this picture, water molecules can easily form hydrogen bond with the adjacent water molecules. At any instance, water is always having a hydrogen bond to its neighboring molecules. Here, we will talk about how the four properties of water, namely cohesive behavior, ability to moderate temperature, expansion upon freezing, and versatility as a solvent, can emerge because of hydrogen bond. Because water molecule is always attracted to another water molecule by hydrogen bond, water molecules are more structured than any other liquids. This makes water molecules very cohesive or easily held together, which you can see it from the video. As the ladybug walks past through the stalk, the water droplets gets attracted together. The cohesion of water molecules also helps transport water from the root to the top of the plant, as evaporation of water at the leaf area pulls water outward due to hydrogen bond through the water conducting cells in plants. Adhesion, also known as the clinging of one substance to another, helps water molecules stick to the cell wall of plants by hydrogen bond against the gravitational pull. Another property as a result of water cohesive behavior is surface tension. Surface tension is a measure of how difficult it is to break the surface of a liquid. Water, because of hydrogen bond between the water molecules, has an unusually high surface tension. As we can see on the left video, at one moment, water droplet was not able to break into the surface of water. The high surface tension also allows this raft spider to walk on the surface of the pond without breaking the surface. Water also helps moderate the temperature of its surrounding. Evidently from this picture, which is a heat map along the coast of California, we can see that the regions closer to the Pacific Ocean has a much cooler average temperature. And as you go further inward away from the coastline, the average temperature increases by about 10 degrees Celsius. Water is really good at absorbing or releasing a relatively large amount of heat with only a little bit of change in its own temperature. This is because water has a relatively high specific heat as compared to other matter. Specific heat is defined as the amount of heat that must be absorbed or lost for 1 gram of that substance to change its temperature by 1 degree Celsius. Therefore, at any given amount of heat energy absorbed, water changes its temperature a lot less compared to other substances. With a stable temperature, water allows the marine life to flourish and allows living organisms to regulate its own temperature. One way many organisms regulate their own body temperature so that it doesn't go super hot under the sun is through evaporative cooling of water, or for some organisms like us, sweating. When water molecules move fast enough by absorbing enough energy, it can break apart the hydrogen bond attraction and escape into the air as a gas molecule or vapor. water happens to be able to absorb a lot of heat energy to be vaporized because of the strength of its hydrogen bond that must be broken. As a result, water has a very high heat of vaporization, which is the quantity of heat a liquid must absorb for 1 gram of it to be evaporated into gaseous state. Water is also one of the few substances that are less dense as a solid than as a liquid. In other words, ice floats on liquid water. This is because as water molecules move slower due to temperature drop, as you can see in this animation, it becomes harder for the water molecules to break the hydrogen bond. And at 0 degrees Celsius, the hydrogen bond pushing each water molecules apart at a locked, organized crystalline structure. This expansion of space allows ice to be less dense and float on top of liquid water, thus allowing marine organisms to thrive below the ice sheet. Water is also a very versatile solvent, a dissolving agent that can dissolve many different types of solutes to form an aqueous solution. A solution is a liquid that is completely homogeneous mixture of 2 or more substances. The reason why water is very good at dissolving substances is because of its hydrogen bond, which allows the water molecules to form a hydration shell around the ions, as shown in here, and thus separates the positive and negative ions apart of the ionic compounds. Water can still form hydrogen bonds with molecules that are not polar, or with large molecules that have ionic and polar regions on their surface. The way we calculate the concentration of solutes in an aqueous solution is by calculating molarity, which is a unit of concentration by calculating the number of moles of solutes per liter of solution. If a substance can be dissolved in water, it is said to be hydrophilic, which means having an affinity for water. As seen here with lots of love, substances that are non-ionic and non-polar or cannot form hydrogen bond with water are hydrophobic or water-fearing. One example of a hydrophobic molecule is oil, because oil doesn't really have any polar covalent bond within the oil molecule. Therefore, it cannot create a polarity to form hydrogen bond with water. Occasionally, a hydrogen ion can transfer from one molecule to another molecule because of the hydrogen bond. A water molecule that loses the hydrogen ion will become a hydroxide ion, while the water that gains a hydrogen ion will become a hydronium ion, which we usually short as hydrogen ions. In pure water, concentration of hydrogen ions and hydroxide ions are equal. Adding certain solutes will modify the concentrations of hydrogen and hydroxide ions. So, an acid is a substance that increases the hydrogen ions concentration of a solution, while a base is a substance that reduces the hydrogen ions concentration of a solution. Scientists use the pH scale to describe whether a solution is acidic or basic. pH is equal to negative log of the concentration of the hydronium ions. 7 is neutral, in which the concentration of hydrogen ions and hydroxide ions are equal in the solution. Notice that as pH decreases from 7 to 0, the number of hydrogen ions is increasing, making the solutions more acidic. As pH increases from 7 to 14, the number of hydrogen ions is decreasing, making the solution more basic. The internal pH of most living cells is close to 7. Therefore, maintaining the pH level of environment is important for living organisms. A buffer is a substance that minimizes changes in concentrations of hydrogen ions and hydroxide ions in a solution. And that's about it. Before the end of the video, don't forget to click the subscribe button, like and comments, as they're just as significant as water. Without water, the living environment as we know it will cease to exist. And your encouragement and feedback would help me to carry out my job even better. However, there's another element that's just as important as water molecule for the living organism, and we will be exploring the fascinating chemistry of this element in the next video. See you next time!